So it's getting recorded, right?
Yes, yes.
Yeah. So first question is like S1, S2, S3 is given. We have to find whether S3 is formed by the interleaving of S1 and S2. So in first example, like it's forming. Like you have to take order. I mean, relative order you have to maintain. Like A should come before B and B should come before C. So it's happening here. Like in second string, D is before B, so that is also satisfied. And A is after C. But same thing if we see here in second string, here A is coming before C, but in the second string, A is coming after C. So because of that reason, it is not forming that interleaving. I mean, you can't form S3 out of S1 and S2. Otherwise, the length in both of the strings are same. Yeah. So how to approach here?
So you are seeing in the example 2, the last CA is
Yeah.
not matching because in S3 it is AC. Okay. Makes sense.
Yeah. Yeah, and A is also, and in second string, A is coming after C, and in your S3, A is coming before C, right?
Yeah.
That also. Yeah, same thing.
Okay. So how big are these strings?
Yeah, they haven't mentioned anything.
Nothing like that, right? Okay.
Yeah.
And but they haven't mentioned that it's going to be lowercase or so the case does matter or not, but I think it should, right? So
Yeah, it should, as long
yeah.
as they haven't mentioned, it should matter. Yeah.
Yeah. Yeah. So what would be the brute force in this?
Brute force, yeah. So,
We actually can combine all these S1, S2s in many different combinations, right? And form different combinations of for S3 and just pick whichever is matching S3.
Tasang, actually I am having some difficulty to understand this questions. Example 2, like I can see in first string S1, C comes after A, right? But in S2, C comes before A. I mean, so what about the relative order you are talking about? I didn't get you at that point of time.
Well, he means that like S2 has CA, right? So you cannot form, and if you look at S3, it is AC only. You have only one combination, AC, right? So AC is not the same as CA. So that's the reason you cannot form a S3 out of that. Because you can't change the order in any of those strings. You have to just use
strings.
the
Okay.
ARTs. Yeah. Yeah, so that is the only way to do, right? So form
Brute force,
different
yeah.
strings. Yeah, brute force. And then, but how do we implement that? I know you can actually use some.
Can you repeat that brute force, Ankush?
No, what I was saying is take S1 and S2 and
Okay.
combine all of these letters as they are. I don't change the order of both of them, but form different combinations of them and then try to compare with S3, the result actually.
Or I can think we can have three pointers. One is referring to S1, second is S2, and third is S3. And if it's matched from, and I will try to match with S3 to any of other two pointer, rest pointer. If it's matching, then I will increment this. And if it is, suppose if it's not matching S1, then I will check S2. If it matches S2, I will increment S2. Similar kind of thing.
I think voice is very low, right? Or
Okay.
Yeah, but in that case, what happens if we have duplicates?
I mean, it won't be a problem, right? So actually, we'll be iterating through each of the characters one by one. So
Because like S1 has A, B, C, C, and if
yeah,
S2 had A, B, 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 C, A, okay, and maybe S3 is matching.
let me
So,
re-explain these things.
okay.
Let's suppose pointer P1 is pointing to character A of S1, P2 is pointing to D of S2 and pointer C is pointing to S3 of A, right? So if I will check whether this pointer P3 is matching any of these pointers. So I can see S1 is matching, right? So I increment the pointer of S1, that is P1, I increment by 1. So now again it will be pointing to next A of S1. And again I will increment this S3. And the S2 pointer will remain at the position D, pointing to D. So next time I got another A, I will see whether it is matched with the S2 or S1. So again I see that S1 is matching. So again I will increment this S1. Now the S1 will be having B, right? Again S2 will be pointing to D here itself, and S3 will move to D. Now I will see D is here, and so S2 is matching. So I increment the S2 pointer and move this to B. Similar kind of thing. So it will be
that will not work actually, because if you have duplicates, let's say in this case you have different letters, that's why your example works. But if you have, let's just for assume that S2 also has 2A in the beginning, what are you going to do about that?
Yeah, so like if you have A, B, C, C, and then you just have A, B, B, C, A. Okay, we just remove the D. Okay, and your example will be A. Okay, instead of B, you have another A. Then B, B, C. Yeah, actually, it will be valid S3. Okay, so you have 1 year. Okay, and 1 year, and this 1 year, right? So you are saying this is A, this is B, and this is C pointer.
Yeah.
So how do you do this in this case? Because here you have A year also, and you have A year also.
Any of these you can move, no problem, because every character has to fit in S3, right? So the length of those S1 plus S2 will be equal to S3, right? So I can move any one of those. You can choose either string 1 or string 2, if your choice, totally up to you. Suppose for this example, I am moving to this S2 only. So this S2 will be moved to B, right? And my S3 will be to the next A of it.
Okay, yeah, I think this is not a good example though, but yeah.
But I think you can, if you take randomly, it won't work, I think so.
It will not work actually, because let's say your example, what you're talking about, first one is A, so we take the S2, right? So S2 goes to B now. And then next time when you go, so since we are looking for next A, so that will be from S1 now. So S1 will be still on the first one.
Now it will move to, after matching it will move to second one, right?
It will move to second. Now S2 is at B basically, but now first 2 letters are, let's say in this example, is from string 1 only. So if you go with this one, actually, go ahead and try this one. This will not work.
Okay.
What I think is your matching order doesn't matter. If your characters does matter, it's only whatever. So here, if double A is, suppose we have this string 3 and this string 1 and 2. String A1 is AABCC and A double BCA. Okay. So it doesn't matter if you match double A of string 1 to the initial double A, or either you meet this double A to the last double A, or either you meet it with the initial A and the last A. What does matter is that your characters are matching. It doesn't matter in whatever pattern you are matching.
Yeah,
so it will work. I think the corner.
I got it.
Yeah. I think the corner case. I think the corner cases would be something different. I think this will work. Most probably it should work.
Yeah, this example is not good, but there might be some place.
Some other
might matter. So what actually everyone is trying to come, like, we'll have to find all possibilities. Like when you move the A as B pointer, first you move A and C. If it doesn't work out, then you'll have to move B first instead of A, So you'll have to do all these combinations.
You have to do backtracking actually in this case.
Right,
actually.
right.
Yeah.
So then it will work.
Why backtracking?
No, not backtracking. 2 recursive equations you can form.
Yeah, if you're not able to obtain a match from any of these strings, then at that point we can simply return false.
Yeah, that's false. Totally false. Yeah, because you cannot.
Because we have to consume both of these strings, right? S1 and S2.
Because see what I'm.
No, that is true. but we should actually try to match. Now in this case, you are matching two characters, right? So it might happen that you will have to match only single character. Right now there are two characters which are matching in the first
Yeah,
example.
it doesn't matter, as somebody pointed out, like basically if you are moving forward with like string A in the example you showed, then that particular A which you have like ignored for now, that would be used later on.
No, I see it. I think it will work because we are just matching. What you're saying is we are not trying to basically, it's not a substring we are trying to match. We are just matching character by character in the order.
Yeah, and the order should only, we are concerned about the order. And this
We are just concerned about order. As long as it does match from either one string, it doesn't matter actually.
It doesn't matter, yes.
Yeah, I think that should work. What about, we're going to do it, there's no match, if there's an extra character. We'll skip, right? There could be extra character, or is that possible? That you might have some extra character like F along the way somewhere in this S3, or it has to be basically exact same string.
So if we have an extra character, then we won't be able to obtain that interleaving, right?
And
so
it will basically be broken. It will fail.
Yeah, the answer would be false in that case.
So yeah, so if we go, I think I agree. Character by character, 3 loop will work. But okay, yeah, that will work. Is there any way we can do without 3 loops, I guess?
It's not 3 loop, it's only the maximum of the S3, I mean, times the S3 actually. In the single loop only way iterating.
So you are saying you are going to do iterative way?
Yeah, iterative only, yes.
Okay.
Yeah, one small check I can see is that if the size of S3 is not equal to the size, like if it's not equal to the sum of these two, S1 and S2, then we can straight away return false.
Yes, straight away.
Yeah.
Okay. So do you want to actually demonstrate the iterative version, at least for the brute force?
Asking to me, Santosh?
Yeah, either of you, because I never thought it will be an iterative version.
Okay, but I don't know. Actually, I don't have any board kind of thing. How I will draw actually.
Okay. So I think the way it was explained, the way they say you should use a recursion, right?
Yeah.
So that is what they were saying. Like if you want, usually you do a recursion.
Okay, I will try to explain step by step. If you can visualize it, then it's okay. Otherwise, somebody can take me from whatever I'm trying to say.
But I think what you're saying, I think code-wise, I think it will work actually. Maybe we should talk about just a recursion one actually and see basically if there's advantage over basically. Recursion, of course, will be more expensive. If we can do iteration, that will be basically faster anyway.
So what I'm trying to say is, I don't think we need recursion over here. Actually, the maximum time the loop will execute is the length of S3, right? And suppose it will start from the 0 to the max, I mean length of the S3, and I will be having 3 pointer. One pointer will be the pointing to the S3, second is S2, and first is S1, or vice versa, whatever you can take. So suppose like at the 0 of, when the 0, I will match with these 2 pointers. If it is match any of those, I will increment those, and I will also increment this S3 pointer, right?
No, I agree that we don't need. I was saying this. Do you want to talk about the second approach now, the recursion also? I'm just saying that.
Okay. So recursion. Okay, recursion. Okay.
I was saying just that basically. I think Sasank or somebody mentioned about recursion. So, do you want to write the code for this one, or do you want to move on to the next approach?
Well, I see Shashank has a recursion already there, right, on the screen.
Oh, it is, okay.
Yeah. So because whatever the way it has been explained, it can be done with recursion and memorization. So it's a DP problem, right? So either you can do top down or bottoms up, but never I've seen the iterative way you guys are saying. Yeah, it looks logical, but there might be some test cases where it might not work. That is what I'm thinking. Because you'll have to at least form different combinations of S1 and S2, you know.
Since we are going letter by letter, what they are explaining, right? You are kind of taking care of all the combinations, so it should work technically. I cannot see
But
that.
you might have to actually change the combinations also in some cases to match with the S3, right? Now you are assuming that it might work because might be the example actually, you know,
Since you are going,
tells you to that
since
way.
you are going character by character and you are incrementing, as order is important. So basically, it has to work, or basically there's no. I mean, I think we can just walk through with this example without writing the code.
Yeah, that's what happens whenever they show examples, they show in such a way that we actually are very, you know, very, what you say, intuited to move that in that direction.
Yeah.
But as it's a DP problem, when it comes to DP, you'll always have to have a recurrence relationship, right?
Oh yeah. So I'm not just denying with the deep.
Yeah. So when you said, yeah, if it's if you are able to find, I think you guys were talking about the iterative version. If that is an easy way of doing it, it will be very straightforward, right? But I don't know. So that would be very good if we can come up with, but or else then this is the way what Shashank has demonstrated over here.
I mean, I don't know.
Oh, who's this?
We can just basically do, if we know two approach, that's better. It's not one versus other. Right?
Absolutely. But that would be very easy to do. Therefore, I was thinking if there is some way we can do it.
Yeah. DP1 basically.
Can someone take a lead in writing this code if possible, the way you guys are talking about? Do you want to do that, or we just go through the recursive version and then anyone?
I have the recursive code, but like I'm out of 190 cases are passing. So
Recursion?
Yeah, the recursive code I have.
With memoization or without memoization?
Memoization, with memoization.
Okay. Okay.
Yeah, there is small trick in the memoization, I think. Yeah. Because the way the normal brute force is, if you try to convert that to a memoized version, it won't work. When you are doing memoization, actually you need to compare the character by character, the way you guys were talking about, right? In the iterative version. So if you do that route, actually it works. Yeah, Dilip, go ahead. Yeah.
Yeah, I'm telling, we'll try to code it and see. It won't take much time, right?
Sure. Anyone wants to go with that? Yeah, Dilip, go ahead.
Yeah. Okay. Like, I'm not completely clear. So, so approach is like that, right? We have 3 pointers. Like.
Yeah, they're saying like you create 3 pointers, and then.
So are we doing it the iterative way or?
Yeah, the iterative way. Yeah. Just give a quick shot to it. We just want to understand what test case it will fail, you know, because it looks very, very logical, right?
Right.
Yeah.
Okay.
So now you have to say S1 IDX1 equals S3 IDX3. Yeah. Or yeah. Okay. Yeah. First.
What should I do in the else case? Like, is there anything I need to do?
I don't think so. You can do that, right?
It doesn't matter. False. Then it returns false, right?
False, yeah.
Okay, then you have to increment IDX3 also. Okay.
Yeah, IDX3 also you have to increment.
Yeah, exactly. Yeah.
Oh, you can't increment outside the loop. Okay.
Yeah, outside. Only one time we have.
It's okay.
Okay.
He has done it. That's fine.
It's Python, so that's why it's not outside the loop. So
Okay. Yeah.
No.
Okay. Is this what you guys were talking about? And then you'll have to say return true at the end, right?
exactly.
Yes, yes.
Will this work? I mean, how are you taking care of order?
Or you are going in order, so you are taking care of order, right?
So this is what you guys were talking about, right?
Yes, yes.
Yeah.
Okay. Just run it.
Let's test it. Actually, we'll know how many pass.
Oh, what's
Out of range.
I said? Okay.
Or you went. You are going basically less than IDX3. So IDX you have in the while condition you have to put more, because IDX you cannot keep incrementing. IDX will fail if it's more than length 1, right?
Yeah, IDX1 should be also less than the length 1.
Length of IDX1 string.
IDX
No. In the if itself. In the if itself, let's also check the length for IDX1 so that we don't need. And yeah, same thing for IDX2. I think that should fix it.
So one thing, let's say
Santosh,
our string
I just
S1 is ABC and S2 is anything and S3 is also ABC.
Yeah, the given string itself does not do.
Yeah, then I don't think it works.
so this is the same thing, right? A B C C B B B C A and A D B C C. Yeah, it failed actually. Can
okay. So the reason why it failed is I just tried to debug it a little. So when it reached to index number 8, okay. So suppose in this you are matching the string number 1 to the main string, okay. So the thing is string 1 matching is already completed, but you have still like AC has to be matched with CA, okay, with string 2, but that doesn't match. So here it's something more like a which thing you should take first to start matching.
Yeah.
Okay, there is something like a force to be deciding which, like something has to be pre-calculated to find which character you need to match, because once your characters are all exhausted of one string, you are just left with like a same ordering. Take this string, okay, string number 3, string number in the example 1, string number 1 and string number 2, okay, and we have this string number 3. So the thing is, if all characters of my string 1 are exhausted, so have reached to I is equal to 5, okay, for string 1, because A, B, C is all matched, okay. For that case, I have reached to the C of string 3, that's index number 8. Okay, now I need to match this CA with AC, okay. Now here is the problem, okay, because we never can match AC to CA, okay, anyway, we can't match. For this, we have to make it very clear that for initial CC, we have to match it with S2, then with S2. So here is why this question seems to be hard.
Yeah, that is the reason, you know, you cannot
yeah, this
one direction. You will have to do for all different combinations, right? And therefore the recursion actually comes into picture.
yeah now we are
Yeah. So that's a good exercise actually. Yeah, because every time whenever we see this is a question, now we know this question, it's very clearly stated, it's a hard question. If we were blank, there is nowhere, okay, then we would have gone this way. Okay, so we always have to be very careful of such things.
No, and also we learned some. I mean, I think that, but your mind doesn't work like you don't. When you see, I think now we know basically what we missed.
Yeah, but I think, you know, so
we all know we were wrong, yeah, but this
simple question, so simple implementation, no one will ask in Leetcode, I think so, right now, at least. This is not even an easy way of implementation. It's a very basic way, like you just want to test your code, you write two loops, and then it works. Yeah. Okay, thank you, Dilip. Yeah, thanks for getting it. So are you going to discuss the recursion also?
So can I ask a question? So today, my first time, so Do you guys post the question somewhere beforehand? It looks like everybody was aware of the question.
Yes, yes.
What-
Actually, they are in the Discord.
I was Discord in the room, like you guys post in the morning or day before?
Day before, one day
Okay.
before.
Okay, I'll take a look at it. Thanks.
No problem. Yeah. Okay. So, Dilip, you want to go with that?
Yeah, okay. I have the memoration with recursion. I can share that.
Okay.
Someone else want to share it? Okay. So okay. First initially I'm checking whether the length of both the strings is not equal to S3. Then I'm returning false. This is like I'm taking a map for the memoration. Then I'm calling interleveling of with 0, 0, 0 as with all the three strings indexes starting with 0, 0, 0. So this is my recursive function interleveling. So that will get if my IDX reach to length of 3, that means I already covered when all the string tree, so I can return true. Or else then I check if this IDX 1, 2, 3 is a tuple, or you can say like a pair with 3 elements like that. So if that one is in my memory, in my mem cache, then I can directly return that. So here I'm using the memorization. If not, then I will check if IDX 1, if string 1 is already exhausted. If that is exhausted, then I will check whether the rest over string 2 matches with rest over string 3. So it will return true or false. The same thing, if the string 2 was exhausted, then I will check if string 1, rest of the string 1 with the rest of the string 3 matches. If that one, okay. So if not in both the case, all these cases, then we go to the case where we see if S1 character matches with S2 and S2 character not matches with S7. So then I will calculate that and store it in the memory.
But do you have to do that AND condition on 37 line number when you say S2 IDX2 not matches S3 IDX3?
Because that will lead me to the case where both matches. Then I need to call both and see which one is best of both. Which will lead.
No, you can call either of them, no?
Yeah, first I can call that, then I can call these cases, but I coded like that. Yeah,
Okay.
You can avoid that AND part, I think.
I can directly remove that. Then it will go if S1 matches and S2 also matches, but even though it will go to this condition only, which is calling only S1 directly.
Okay. Maybe that is the way he implemented, but it's good to be very explicit. That's the thing I liked about it.
Yeah. I got it now. After you raise it, I thought maybe this condition, if I raise it first, then I don't need to make that AND condition after later. So say if S2 doesn't matches and S1 doesn't match and S2 matches, then I will call with incrementing S2 index and S3. This is the third case where both the characters matches with both of them. Then I'm calling S1 and also calling S2 with an OR operator, so that if any one of them returns true, then I will have the mem with the true. If not, all of this doesn't mean that both S1 doesn't match to S3 and S2 doesn't match to S3, so it returns false. And then I will return this, what do you call?
Yeah, makes sense.
So in memory table, where are you storing it? Okay, yeah, the result of interleaving we get stored.
Every time is storing it, yeah, wherever he returns it. Yeah. Yeah, even though it's all conditions you have explicitly said, it's always good to do that route, right? Because you might miss something, and then when you try to debug recursion, it's slightly painful. Yeah. Okay, but in the last one, okay, when you say and, then you are doing or both of them, that is okay. But if it is okay, so you're trying to be only explicit for, okay, I got it. Yeah, this is good.
Yeah.
Any questions on this one? Okay. So yeah, no problem. So Shashank, you had that one, right?
Yeah, just similar on whatever Dilip has said. You will share
Okay.
it.
Okay, please.
So it's the same thing. I mean, first base condition is like if the length itself doesn't match, you return there false itself. Otherwise, we are calling this helper function. So S1, S2, and initially 0, 0 index. So next, what like it's if you're, I mean, I has already covered the entire length of the string, or J has covered. Then we are checking if remaining of them is matching with the remaining of the, what do you say, the
Okay, the
final
other
string.
one.
These three things. Yeah. Then if it is true, then it will return true else if it is false, then it will return false. And if the result is already present your memo table, you just return from there. And I've initialized result to false initially, and just these two equations. So if first character of S1 matches with the third with the that particular character of S3, then you increase the pointer in the first one, and yeah, in the first one, and then call the helper function on that.
Because S1 is matching, right? Yeah.
Matching, yes. And same like here, S2 you can do in S2 and then call the helper function. And then storing the result. Yeah, that's it.
Okay, so in your case, what is different than what Dilip presented was?
That equal to case.
Yeah, the equal to case. You are not doing ORing, right? You are actually explicitly looking for each one separately.
Yeah.
Okay, so in his case, if he would have avoided the last OR, it would have worked, right? I'm just sorry.
Come again.
I'm just thinking loud. In his case, if he would have avoided the last case where he said, okay, both of them match, I will do an ORing for both of them. So if he would have even commented that, it
should have worked.
It should work. It seems like okay.
Looks
maybe,
like
yeah, it can be tried. Okay, thank you. That's
yeah, but
good.
Dilip has explicitly mentioned all the conditions. Like
yeah. So that is everything, So whatever you want to know, actually, is everything there. Yeah.
But Rishank, in this case, what if I and J both matches with S3 of I plus J? In that case, won't you be considering only the S1?
No, but it can go for S2 also. I mean, you're
because
saying
it's
that
a recursion, right? So it will go to 19 either or 21 line.
No, but
it will go to S2 only, but that doesn't matter.
Either with matches with first one or second one.
Yeah.
No, my question is, let's say there's a string AB and there's a string AC, and the S3 is ACAB. Okay.
Okay.
So for the string, on line number 19, S of I will match with S3 of I plus J, right?
Yeah.
Right.
So you will call on S1, S2, and I will be now 1 and J will be 0, right?
Yes.
But eventually when it will return false, right?
Yeah.
So, but since it went to the if call, it will not go to the elif call, right? No, it will go.
It will go after completing this.
Yeah, my bad. It will go. Sorry, thanks.
Yeah.
Okay, that's good.
Then,
so we have any bottoms up approach?
So.
Okay, if not, then actually I have one.
Yeah,
which I have taken the help of the solution. It's almost the same, but I'll just share that.
Also for bottom up, can't we just do the reverse? I mean, just start from length -1 and come to the top, maybe?
Yeah, you can do that way also. You want to say, you're saying that you can start from the backside of the strings, right?
Right.
It might be possible.
LCS kind of, right?
It should be possible, I would say, yeah.
The longest
you can do either way, yeah.
But order will be, only the problem is of odd. Yeah, it should
we will maintain the order, right? In bottom up, whatever the way you take, left to right, right to left. It should not be a problem.
Yeah.
Okay, so this is the DP array, which will have N1 and N2 are nothing but this lengths of S1 and S2, and N3 is S3's length. So I'm actually having a DP array of N1 plus 1 rows and N2 plus 1 columns. And I'm iterating here the outer loop with all the rows and here going through the columns. So the base case, okay, I equals 0 and j equal to 0. This will be true because I'm having taking this as a Boolean, yeah, 2-dimensional. And if I equal to 0, in this case, then what I'm going to do is actually just looking for actually the j minus 1, which is the previous one in that column. And also when I'm looking, I just want to compare whether S2 of j minus 1 equals to S3's of I plus 1 minus 1, I plus j minus 1. Okay, in the same case, I'm doing for j equals 0. When I'm doing it for j, I'm looking for the upper row, right, in this case. And same time, I'm actually comparing with the S1 also, because S1 actually is my rows and S2 is my column, correct? So that is the way it is. And then at the end, look for both of them together, the way actually Dilip did, right? So in this case, actually, I'm doing an or both of them. And that's the way the bottoms up. At the end, then actually look for DP of N1 and N2.
It almost looks like, top down, but with a, not top down. Yeah, it's a bottom up, but the concept is same only, right? Like,
yeah, what Dilip did actually, it was almost the same. But only thing he has explicitly said in some cases. But these are like when I equals 0. Okay, means when the row is 0, and this is when the column is 0. Okay, and this is the actual place where it is when column and row both are not 0. So then you have to do for both the comparisons.
and if both your strings are empty, that is a base case. It will return true in that case. Both the strings are empty, right?
If both strings are empty,
you return.
If both strings are empty and N3 is not empty, then it will return false from here, right?
Yeah, it will return false. Like, if both are empty and S3 is also empty, then in that case, it will return true.
It has to return true.
True, yeah.
Because the base case here will be true in that case, right?
Yeah.
So then we are just looking for that, and then it will return from here.
So in line number 15, if I is equal to 0 and j is equal to 0, you are putting this as true.
Yeah.
Right. So what is the logic behind this? We're not incorporating C anywhere, the third string.
Because
okay, so it's like both are empty, right? The way he said, right?
Then C will be automatically 0 because already line number 7 he has checked, N3 is not equal to N plus N2. If it is 0 plus U, then definitely N3 has to be 0.
So exactly what Shashank said, like both of them are empty, then S3 is also empty, then it should be true. Yeah.
Santosh?
Yeah.
Sorry if I missed something. Can you just tell us in table how you are filling true and false? I can't make out of it.
Can you mute Shashank?
Yeah, sure. I'll mute.
Okay. Yeah.
I can't make out. If I miss something, sorry. But can you make out a table how you are filling it? Just to get
okay,
an
sure.
idea.
Let's go through that. No problem.
Yeah, that's.
I will also be.
Just tell the approach, okay? Don't worry of the code.
Okay, now in that case, I don't have this. Okay, I don't know how to write then. Okay, let me copy this in my. Okay, and then I'll try to draw it there. So I'll stop sharing. And then this will be whiteboarding, maybe. I'll try this. Okay. How do I copy the text?
Yeah.
Okay, I don't know how. This is not so good copy, but that's fine. This is not going to work. Okay, I just want those. Okay, I'm not sure whether I can go down. Okay, so can you someone give me the example?
Yeah, sure.
Yeah.
So,
S1.
Yeah, that will be good.
is somebody saying? Okay, S1 is your this double A B double C.
Double A B double C.
Yeah.
Huh?
And S2 is D double B C A.
D double B C A. And what is
Yeah.
S3?
S3 is double A
Mm-hmm.
D
Mm-hmm.
double B
Double B.
C, yeah, C
Uh-huh.
BC AC.
CBC
AC.
AC. Okay. Okay. So now what we are saying, like this is 1, 2, 3, 4, 5, right? 1, 2,
Yeah,
3,
10.
4, 5. This was 5 and this is also 5. Okay. So the table what I was constructing was something like it was about 6 rows and 6 columns, right? 1, 2, 3, 4, 5, 6, right? So if I take S1 here in the rows, okay, S2 over here. So this is my extra row. So I just ignore that. And S2 will start from here, D, B, B, C, A, right? Oh man, this is D, B, B, C, A. And S1, this is my extra 1, 2, 3, 4, 5. So this was A, B, C, C. Correct. And this will be true. This is my base case. Okay. And then what I'm trying to do when I'm going from S2 to S1, I'm actually looking for S3 also. Now when I'm this one is 0, row is 0. So what I'm looking for, I can't see my code over here now, but okay. So if my S1, okay, what was that? Okay, let me quickly follow that also. Just a minute.
You can directly rub, take those two recursion relation. That's it. Remove this code.
Yeah, okay.
Yeah,
But
that
then
will be
I won't be able to remove that also right now.
better.
Okay, yeah. So let me just remove from here and then. No, I can't do that either. Yeah, okay. Just a minute.
Can't you save it? No.
Just a minute. Okay, I'll just look what it is written here. When my I equals 0, then I'm looking for S2. Correct. Okay. When I'm I 0, okay, I 0, I'm looking for S2. So S2, I'm comparing this D, okay, with B. Okay, so this is not true in this case, right? So D, actually my S3 pointing to whatever. So now my I1, I can't write it here now.
Can we send you the code on the chat and then you can refer?
So that is fine, but now I'm not sure how I can write it here. Okay.
Okay.
What's happening?
You can say I can annotate at place.
How do I annotate?
No, I'll annotate it like from here. Only true false I have to write. That's it, right?
Yeah. So in this case now, if we see for the first row, okay, if we compare the first row, so your S2, which is D, okay, this will be false, right? Because D is not matching with S3's A. Because now if you look for I and J, if we say, I is 0 and J will also be 0. So I plus 0 and whatever that minus 1 it was saying, right?
Yeah.
So that is also not equal. So this will be false. Then B also will be false, right? So it is not matching. If we compare with S2, oh man, why I'm not getting that? Where do I do annotate? I think you should go to more.
Yeah. Should
Okay.
be.
Okay, maybe I'll just stop sharing and again share it. Will that be there? Okay. Yeah, okay, sorry. Yeah, it is there. Now, if I say, what I was talking about, I is equal to S1 actually. So I is 0 and J is also 0. And my I plus J and whatever that 1 minus 1. So in this case now I will be, so I is 0 and J will be 1, right? So I plus 1, so J will be 1. So I plus 1 plus 0 minus 1 will be 0. So if I compare this with this one, it is not matching and therefore this is false, right? So then I go to B. So if I do it simultaneously, this also will be false, right? So this will also be false. Correct?
Entire row will be false.
Yeah, so all of them will be false, right? So then I do for the next one. In that case, now when I come for this particular, so in this case, my J is 0. So when my J is 0, I'm going to compare with string S1 for this particular case. So now this is A, correct? So my string A and this both are there. So, but my J is again 0 and this is also 0. So I plus J, both of them are 0. And so this will be...
I is not 0, right? I is 1.
Oh, sorry, I is 1. So I minus 1. So I'm just comparing this guy with A. So this is true in this case, correct?
Right.
Yeah, and then I go over here. Then I go for this one. So when I... So in this case, okay, let me actually have that relationship because it's very difficult for me to...
No, here S2 is empty, right? And S1 having character. So it should be false only, right?
No, but this is the base case. Like if S2 is empty, now you check your S3 with S1, character by character. So since we are at the J equal to 0 column, we are checking character by character and A matches.
Matches, okay then.
Okay, so if I just paste this text over here, okay. Okay, so this is the, okay, so in this case now if you look for, okay, oh man, this is again,
It became less.
okay, it became worse. Can we not delete this anyway? Okay.
New.
There'll be some option for erase, I think.
Might be option, might be there definitely.
Oh yeah, I can't even do this. Okay, now this is gone. Okay, if I just put it over here for now, but then I'm not going to see this. Okay, can I redraw it again? I clear the overlay. Okay, and then, okay, so.
If somebody is saying in Leetcode there is a visualization, so it will be more better to go through.
Okay, now. I'm sorry. So this is one. Okay. Okay. So can someone give me S1? A.
Double B. Sorry, double A.
Okay.
B double C.
B double C. Okay. And then what is S2?
S2 is D double B.
D double B.
No, D double B.
D double B. Okay.
Yeah, and CA.
CA. And what is S3?
Your S3 is like double A. D double B. CBC. And AC.
Okay. So let us draw this one. Okay, I'll just quickly draw now. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. And this is my S2. So this will be D, B, B, C, A. And this will be A, B, C, C. Okay, so this is my base case. This will be true. Okay, as per that one. The first one. So now when I go in this one, when my I is 0, so this is I and this is J. So when my I is 0, in that case, what I'm trying to do is I'm actually trying to look for if J minus 1 is true And so j minus 1 will be, j will be here, so which will be 1. J minus 1 is true, but then along with that I need to compare S2 with this one. So this is not true, so this will be false, and hence all of them are going to be false the same way. So now if I come for I equals j equals 0 in this case, and when I equals 1, in that case I'm going to look for I minus 1, which is true, this one. But along with that, I need to look for S of I minus 1, which is this one, and I have to compare that with S3 of this guy. So both of them are true, and hence this guy will be true. Okay. So, but when I come here, actually, I'm going for the else statement here. So in that case, I have to look for either the one which is before in the column, this guy is true. Okay, or this is true, either of them. If both of them, either of them is true, I just mark that as true over here, right? Because if I say, if I say I minus 1, okay, if I compare this one, but this is false, I don't compare that at all because that's useless. But then if I go for j minus 1, which is true, okay, and then I compare S2 of j minus 1, S2 of j minus 1 will be, j minus 1 will be in this case 0, right? Yeah. So j minus 1, okay, so then I'm comparing S2 of j minus 1, this will be 1 in this case, so S2 will be this guy, right? And then I'm going to look for, so okay, so this will be false in this case, correct? Both of them are false. Yeah. Okay, so then I move ahead, then I go for, I'll have to go again in the else statement for this one also. So in this case, I look for both of them are false. So this is also going to be false. This is going to be false, right? Because they are all false, right? So then I come for A in this case. When I come for A here, my now I is 2. Okay, so I is 2, I'm comparing this with this guy, right?
Yeah,
Because 2 plus 1, so this will be true. Okay, when this is true, then I come and look for here. In this case also, this is going to be false, but I look for this true. So this is also going to be false in this case, correct? Okay, so all of them will be false.
No, why S2 plus, this would be S2 of 1, right?
Which one?
Uh,
okay, so
I equal to 2 and j equal to 1.
So I equals 2 and j equals 1, right? So if I look for I equals 2, so in this case, so I cannot look for the one on the top. Okay, so I minus 1 is out of question. So I just look for j minus 1. So j is S2 minus 1. 1 minus 1 is 0. So which is D, right? And 2 plus 1 minus 1 will be 2. Okay, so 0, 1, 2. Okay, in this case, this will be true. Yeah, you're right. So this will be true. Okay, so then if I move ahead in this case, when I come here, so my j will be 2. So in that case, if I compare both of them,
S2 of 2 and S3 of 2 plus 2 minus 1.
So this will be 3. So 0, 1, 2, 3. So this will be B.
Again true.
This will also be true. Yeah, you are right. And then I think other than that, none of them will be true in this case, right? So if even this is false, when I look for this one, so in this case, this
I think we'll have one more true.
So 2, this is 0, 1, 2. Well, how can this be? J is not 2 here. J is 2 here. So we went the other way, right? Okay. So j should be 0, 1. This is 2. But now when j is 3, right? So in this case, right? So this won't be true, right? I plus 2, 3 plus 2, 5, minus 1 will be 4. So this should be false, right? In this case, 0, 1, 2, 3, 4, 5.
I equal to 2 and j equal to 3. So we'll be checking S2 of 2, right? And that is B. And we are checking S3 of 2 plus 3 minus 1. That is 4. 0, 1, 2, 3, 4. So that is B, right? So that would be true, no?
So, okay, I equals 2 and j equals 0, 1, 2. In this case, it is 3, right? Okay,
Yeah.
if I consider this one. Okay, so I plus 2, 3, and this will be 4, okay, for S3, right?
Yeah.
So if you look for 4, 0, 1, 2, 3, 4, which is B, and
Right.
and I'm looking for S2 of J minus 1, which is equal to 0, 1, 2. Yeah, this also B, this is also true, you're right. Okay, so in this case, I think this won't be true at least, right? Okay, so now I will be increased to 4 and this will be 5. So I'm here, I'm looking for this value, and then I look for J is
Again true.
yeah, this is also true. Okay, yeah, okay, and then I go for one more. So in this case, this will be 5 and
Now
this will be 6. So I'm looking for this one, and then if I look for, so this will be false, correct?
right.
Because I cannot compare A with B. Okay, then in this B, if I do for, so the same way of AA, and then I look for, now in this case,
It will
I
be
have
true
to
now.
look for J equals 0, J equals 0 and I minus 1, this is true. And then S minus 1, I will be 3 in this case, right? 3 minus 1 will be 0, 1, 2. And then I'm comparing. Okay, so what is my I? Let me erase this again. Okay, so what is my I in this case? It is 3 and J equals 0. So my value of this will be 2, 0, 1, 2. So I'm just comparing B here. So when I compare B with I minus 3 or D, this is not true. So this will be false, correct?
3 minus 2, right.
So this will be false in this case. And then I come here. So this is false. Then I have to look for, so in this case, J will be 1. And this S3's value will be 3 plus 1, 4. Okay, 3 plus 1, 4. And then this will be 3. So I'm just looking for B in this case. And then I'm looking for P. Okay, and then okay, so yeah, so this this is the way it will continue. Okay, so at the end somewhere it has to come converge to this true. Yeah, but if you do it that way, yeah, but it's slightly complex to actually visualize though.
So basically,
Yeah.
if we try to gauge the intuition behind this, we are trying to kind of go one letter back, not one letter back, like one state back for a particular string and check the like current, what do you say, current character of that S1 and S3. Right? It's a bit complicated.
Yeah, so yes.
Thanks,
So
Santosh. I think this makes a lot of sense. Yeah.
Yeah.
It is very clear now. Yeah.
Yeah, it's a very difficult exercise though, but yeah, that's right. Should have practiced more before the session. Yeah, that's right. No problem. Thanks for bearing me. Yeah, guys, go ahead.
Thank you.
There's a lot of time.
Yeah, we spent about 1 hour in this.
Yeah, and we we can switch to next.
Yeah.
Okay, sort list. So next, this one is the next one. Yeah, sort list. So linked list, sort a linked list in O and log n time using the constant space complexity. So this is the sorted from O. I mean 1, 2, 3, 4. Kind of merge sort because of time complexity, and this is again sorted. So yeah, that much.
Yeah.
So
can't we use all general sorting algorithms like on arrays on the list?
Yeah, we can.
Bubble sort or sort.
Okay. Bubble.
So what are you trying to say? To get in an array?
No, I'm saying Shashank said merge sort we can use. So is there any advantage with the merge sort?
The complexity.
Yeah, because he's
Complexity.
saying you have to do it in n log n time, right?
Yeah.
I mean, okay, quicksort, we can also use quicksort, but I thought maybe medsort is somewhat easier with linker list, something like that. But okay.
Merge sorts or worst case is also in log n, right?
Yeah. I mean, we can use quicksort also, right?
Yeah.
But in Quicksort, if you do a partition, you'll have to still go through O of n, right, every time.
Yeah.
I'm not sure how you can do a Quicksort in
maybe
a
we can
Linklist.
maybe we can take two pointer that that means like equal to that pointer means we reach the end of that sub array.
Mm-hmm.
Also, the worst case for quicksort is not n log n.
Yeah.
Worst case is n square, right?
Yeah.
Yeah, I think why merge sort is more favorable for linked list, because at least you can merge two lists, right?
Yeah.
So you're merging two lists you can do with O of n. So, and also dividing two lists might be lesser than at least n log n, but it will be at least n, lesser than or equal to n. Right? You can divide the two strings or two lists and then do a merge sort.
Yeah. Divide the link into two parts and then do the merge.
Yeah.
But this is a very famous question. Why quicksort is preferred for arrays and merge sort for linked list?
Yeah.
So they talk about some locality of reference and something like that.
Mm-hmm. So the way I look at it, like if you have to divide this linked list, we can use that fast pointer concept, right?
Okay.
So
Yeah,
you
to
can
get the
actually, to get the middle of the string, and then you actually explicitly break the two strings, the two lists,
and
then
normal
keep on doing that, and then at the end you merge it.
Yeah, just like merge sort, yes.
Yeah. Yeah, okay, yeah. So, sorry, I think you almost.
So what is brute force? Is that, I mean, brute, they have already specified the time, right?
So I think there is no brute force. That is the only way we can do, right?
Exactly, yeah.
Okay. So yeah, I think you already have that, right?
Yeah. So it's like saying what you told, like use the slow fast pointer approach to get the mid. So these are base cases, like if your head is none, return, or you have only one node in the list, then you return from there, just return the head. I'm keeping slow pointer on head and fast pointer also on head. And as long as your fast pointer and fast pointers next is not null, then I mean, I've taken a temp in which I'm keeping the slow pointer and increasing the slow pointer by 1 and fast pointer by, what do you say?
Twice.
2.
Temp none is like it will, when the slow pointer will end, after that we'll put none so that it will break into two parts. I mean, list will be divided into two parts. We have to break the list, right?
Right.
Yeah.
But okay, so you are storing the slow pointer. Okay. Mm-hmm.
Two pointer, yeah. Like let's say you reached I mean, let's say this is the mid here, then his next I'll make it mid, sorry, none, so that this will be one list and this will be one list.
Yeah.
And yeah, so I mean, on left side I'm calling this and on right side, I mean, we'll get the head pointer of these two, what do you say, in left and the right, and on these two we are running the merge function. So merge function is nothing like I've created a dummy node and storing and dummy node will keep on moving, and I mean, to that dummy node I've assigned a pointer called sorted PTR. Now as long as L1 and L2 are the pointers on both the, what do you say, both the list, like L1 will be on left side and L2 will be on right side, and if L1's value is greater than L2, then you have to sort it in descending, right? Ascending order, yeah.
No,
Then
it's okay.
the sorted pointer, the smaller value we are appending and increasing the its, what do you say, to the next other I mean, this is the other case, like whichever is smaller. I mean, L1 is smaller in this case, so L1 we are pointing and increasing the pointer on L1, and at last this will be, what do you say, it will append both once. What do you? I mean, not append, like on the main list you'll keep on appending. So every time you append a node sorted pointer, you have to increase the pointer on that, right?
Yeah.
Yeah, and this is like if you are left with L1, then directly append that, and if you are left with L2, directly append that, and at last dummy node dot next, because you don't need the dummy node.
That's correct.
Yeah.
I have a doubt. Sorry. Hello.
Yeah, go ahead.
Yeah, in example 2, so why they appended 0 after 1, because the 2 is not present. So will it that the case?
No, it is not 0. It is -1, then 0, right?
Okay, it's
Yeah.
-1. Okay. Sorry.
Yeah, no problem. Yeah, so I think this is the classical way, right, of a merge sort, and exactly the way that is the standard way which we usually has to be done, right? Using a dummy node. So the merge part is more complex than actually the, what do you say, breaking that into two lists, correct?
Yeah, and this is in place, right? We're just using this line number 29 as extra space, which is constant.
Yeah, it is a constant space. Yeah.
Yeah.
I think that's the only way can be solved. Yeah, there might be different variations to this implementation, but I would say this is a very standard way of doing, and it's very easy to follow.
Like,
yeah.
If someone has some other way to share it. So shall we switch to next?
Yeah, because I think everyone will almost do this way only. But the only thing, I'm not sure how it can be done the quicksort way. Yeah, it might be possible, though I don't know. No. Is it really possible?
But after looking the code, now I feel merge is easier.
Yeah. Quicksort might be possible, therefore, right? Yeah.
I was thinking like we take the last node and see if any node is greater than we push it after that node. We delete here and put it at the end that way. But I didn't implement it. I just thought.
Okay, so the last node, like when you create a partition at that time.
Every time I take my pivot element as last node, and from the starting I iterate on the list, and if something is greater than that, I delete it here and append at the end.
Oh, okay. Yeah, that might be easier to implement also, right? Because normal quicksort is slightly tricky.
Yeah.
So it is possible to implement quicksort also in this case. Yeah.
Yeah, they have implemented.
Yeah, that's good.
But I mean, again, in interview, like it will be, we are used to this. Like, I mean, we know both the sub problems, right? Finding the mid and then merging them.
Yeah.
Right. If you go through it, I think the way Dilip is explaining might be easier, right?
Yeah. Instead of the merge part, we have the partition function.
Yeah. Because you look at the partition value and just traverse through the whole list, and whenever you find any value which is greater than the pivot value, just form a separate list where you append all those values to the pivot element.
No,
and
why
then
even
keep
a
on
separate list? Like we can keep on appending to the tail, no?
Keep on appending to the
tail.
Tail, because that is what will be the pivot. So you'll have to remove it, right?
Yeah, remove and just append to the tail.
Yeah, append, or maybe don't remove it also. Yeah, because it will be a single string. Yeah. That's a good one actually. But in the worst case, it might be again n square.
Yeah.
N square only. Yeah.
So like when we are done with one partition, and as the quicksort says that we have to call for the like the two partitions we have obtained, we have to look for the position of our last element, which like our pivot, which is now being changed, right?
No.
Because that would shift.
So initially we are taking our like some pivot point to the last element and moving all the elements to the after that, right? So
Right.
that would be the end pointer for the first partition and the starting pointer for the other partition.
Right. So yeah. So
Even
after
going
this
deeper,
partition,
yeah.
so after you have done with the after you're done with the partitioning part, what you have chosen as the pivot, that position of the pivot would change, right? It would come somewhere in between.
Yeah. So maybe something like you are trying to sort the left part of that. You take the previous pivot pointer, take it as an end pointer. So until that you need to sort it, and now take the pivot as before that or something else in that before that pointer. Yeah, it won't be in long easy, but yeah.
Okay. Yeah. Yeah. Let's move to the next one then.
Yeah, sure. This is Magic Dictionary. So we want to implement a data structure that will be initialized with a list of distinct strings. Then you'll be given another string, and you have to find whether if you can change exactly one letter of the string to match any string in the data structure. So this is the initializing the object, and the function build it sets the data structure with an array of distinct strings, and it's a Boolean function returns true if you can change exactly one character in the word to match any string in the data structure, otherwise return false. Yeah. So
Okay. So what he's saying is, okay, let's go to the example. Yeah, that will be more clear.
yeah, sure. So first they are instantiating, right?
Yeah, they are actually creating using hello and Leetcode. These are the two where they build that dictionary, the magic
Yeah.
dictionary. So
Then
we
they are
have
searching.
only two words in that. Now when
Yeah.
we search for hello, okay, we find hello. So why we have to return false?
Yeah, that is the
So it says that you have to find such a string which can be obtained by changing one character from the search string. Right.
okay.
So
Yeah.
when you pass this hello HELLO to your search function, you already have the same hello in your map. So you cannot fulfill that criteria which it says. Like if you scroll up, you understand.
Yeah.
Can you please scroll up? Yeah,
Yeah. So you can change
Exactly
exactly
one
one
character.
character word.
okay.
If
So
like
you
if
cannot have the same word, but you can have a different word. Okay.
yeah, and different word has to be like we should be able to obtain something in the map from that different word by changing exactly one character.
Right, right. So in this case, it doesn't satisfy because hello is already there, and it's all the letters are matching. So it's not matching our criteria of search. So therefore, it is returning false. Okay, makes sense. So that is very one thing which we have to be very careful. And then if we go for search HHLLO, this satisfies because E and H in the first
Replacement.
first index actually they don't match, and therefore, but if we actually use hello, because if we replace that H of index 1 with E, then you will be able to find hello, and therefore this is a match as per the criteria, and therefore it returns true. Okay, but it doesn't happen for hell, because even if we have hell, because the length itself is smaller than hello, right? Because we can't add anything after that. We just have to use only that string of the same length.
Right.
Okay. And Leetcode, both of them are again, they have different lengths, so that also is false. Yeah, so makes sense. Yeah, so it is not a very straightforward dictionary. We just have to look for in the dictionary, but we'll have to change each and every character and see if the character distance is only just one distance away from the main string. Okay. So we have any other example other than this? No, right?
No,
Okay,
we have
so
constraints.
So the constraints are like we can have a lowercase English letters. That's very good. And then the length is 100, as well as the length of each and every word is also 100. 1 to 100. All strings in the dictionary are distinct. That is also better. And then the search word length is also going to be between 1 to 100. Search word also will have lowercase English letters. Okay, and at most 100 calls will be made to search and build it. Okay, there will be many calls that way. Yeah, okay. Okay, so what is the best way to do? A brute force or a non-brute force?
I was thinking like if we can construct this character count, like a means like index 0 and count of number of A's means if we have 3 A's, then 0 index will have 3 count, so on like that. So anyway, that length will be 26 because we have only small English letter characters, and we group them into the length and see which one has at least one difference.
Okay.
So if you have your search string as HELO, then I think that would fail. Because for HELLO, the count would be same as HELO. I mean,
no,
count of the
L count. I said like we take only same length strings. Like they're both like we group them.
So you're bucketing of all same length strings and putting in a map, right?
Yeah, like a map. Okay, a map with that count, character count.
Okay, so that will be the key. The count will be the key, and then you will be adding all those strings as a value to that particular key. Is that what you're saying?
I thought maybe we can have a key with value. So anyway, we need to iterate all the length. If we have like 5 strings with the 3 length, and if our input is 3 length, we need to iterate all of them and see if anyone has the same similar array count with one difference. Like I don't know, maybe if we can put it in map, then maybe we can do it in one. Or
No, actually, the way you want actually.
Sorry.
As Santosh was saying that we can keep the length as the key, and as the value we can use another map.
Yeah, okay. That we can do, like length and all the that length characters in the list in the map. Yeah.
Right, and then we can, in the second map which we are using is the value, for that map as the key we can store this string, and or like, and the count for each character as the value, something like that.
Yeah. Then for each input we see like we go to the first map, and for each string in that check if it has same array count with this one. I mean like one with one difference.
Hey, Shashank, can you mute, please? Yeah. Thank you. Yeah, please unmute whoever is actually talking. Dilip and Arshad, yeah.
Yeah. So like okay, let me. So like as we talk, we can have length with all the strings as a list. We can have all the strings of same length. Like for one length, we can have this is one map, and maybe other map with a string and an array which have counts of the character. Like this is A until this is Z. If we have 2 A's in the string, we can have it 2, 1 Z in here, then 1, and so on like that. And so if we got an input of this length for each string in this map, we check if it has the same array count with one difference. Okay, so order also matters, right?
Yeah.
No.
Yeah, order also matters. Like we need to have in the same position. One can be different. Then it will work.
Okay, right.
Sorry.
Okay. So what I was thinking, like, you can have two different data structures. One would be like you put all of these list, okay, in a set. Okay, and second, what we can do, I think that will be too much of space though, but use each and every word. Like here we have hello, right? And in this hello, actually, we can form, like use something like a star, the classic word I was using for some other thing. Like you have a star for every time you replace each and every character with a star, and then store that in a map and increments its count. So if I do a hello, it will be like this. Then it will be, this will be star LLO, right? And then it will be H, then again star LO. And then every time they put that in a map and keep on incrementing the count, right? So whenever you go for a search, okay, for the search also you start doing the same way. Okay, but whenever you hit on, okay, maybe in the second one, we are actually coming here. And if you find the count is equal to 2, then actually we can say that this is true. Okay, because the criteria what we were discussing earlier, right? The one which was like hello, and we should have another word also, right? So if it is 2, then only you say it is, or if it is 1, you actually don't say it is true. Something like that, right?
Instead of map, when you have the input for search, you try to find all of them and see if it is there in this unordered map or something.
Mm-hmm.
Like we got the input and we already construct this whole this star replacement of star as an unordered map.
Mm-hmm.
And when we got the input, we try we start at all the positions and see if it is there in that unordered map.
Right.
I mean, like, yeah, instead of counting and like that.
Yeah, so the way it was, like if we have if it is at least greater than 1, then it is true, or else if it is equal to 1, but if we don't find a value in the what you say in the set, then actually we can say that it is, because we can actually look for this word. If this word is not found in the set, and if the count is 1, it still means it is fine, right? Because it can be other word which has a similar mapping of that star, the generic string, right? So there will be two conditions to be taken care of. But I think it is more in terms of the space, because we are using two data structures, right? So
Can
that
I
might be an
suggest?
efficient way of doing it. Yeah, so go ahead.
Yeah. So, like someone was saying, like we can maintain the hash map of the count of number of letters in each word in the dictionary, and like against the count, we can store the array list of all the words with that count, whichever are given in the hash map, in the given list. Sorry. So what I'm saying, for example, maintaining the hash map of like length versus list of all the words with that length given in the input string. So now if when we want to search some word, then go to that length and look for all the words, and for each word just see if that word is one distant apart. If that's the case, then return true.
But as we discussed, Komal, the ordering also matters.
Yeah, so
You can have
we'll write.
random. Yeah, go on.
So there is in cracking the coding interview, there is one function which she has discussed, and like to find the one distance apart strings. So as soon as we see the differences, as soon as we notice the first difference in the two strings which we are matching, we should flag it. And next time again, if we see some letter different in both the strings, then we should return false.
So is that edit distance or what? Like difference?
Edit one distance apart, something like that. Yes.
So you'll take the set of both of them and get the difference.
No. For example, let's say let's consider the string hello in our map. For
Can
example,
you annotate? Can you annotate?
Yeah, if you can annotate it, will be great.
You mean I give the example, right?
Write it down on the screen.
Oh, sorry, I don't have the. Let's see, I can try. Okay, I can. Okay, great. Sorry. So I'll use the red color maybe. So for example, let's say in the hash map we are saving like count wise. For example, we have a string of length 3, which is ABC. Now we want to search for some string which is ABB. Now we want to search this. It should return true, right? So what we will do, we will check like A match, okay, B match. For example, B, C, they don't match. So I will say, for example, maintain a flag like difference found equals true. Now, for example, did you understand? So now, for example, if we find something like C and D here for length 4 string, I'm talking. So for length 4 string, if now we already found the difference at B and C in the letter 3. So for the next letter, like C and D again differ, then there is already the flag is true. So we should return false in that case. Am I making sense?
Right, but are you using a map here, or it's just two-pointer approach?
Yeah, two-pointer approach. In the hash map, we will store the count versus all the strings of that count.
Okay.
Not all
if
the
you have
permutations, just simple strings.
Okay.
Like,
yeah. But if you have 100 strings of length 3, each of length of 100, and your search string also have 100 length, then I think that's going to consume some.
Yeah. That might.
I think it would be m into n, right, in the worst case.
Yeah.
Because
if only last two letters are different for 100 strings, so then we'll have to go for each and every length of the string.
It should be m plus n, right? Or m.
Can you scroll up, Shashank?
Yeah, sure.
It will be the length of the string multiplied by the number of strings.
Yes.
No, like down for the constraints.
Okay, down. Oh, constraints.
Yeah. So 100 into 100. So this is gonna work fine, I think.
It might get accepted, but the only thing is it might consume more time. Yeah, I think this is also a good way of implementing, I would say. Yeah, not a problem.
10 to the power 6 it would be in the worst case.
Hey, so I have a question. Like over here, let's say we have two strings of length 4, okay? One is HELL and one is HEEL. They are the input to my dictionary. They are already 1 apart, right? There's like at a distance of 1. Yeah. Now, if I'm looking for HEEL, right? It technically exists in the dictionary, but if we first compare with HELL, we get an edit distance of 1, right? So do we, like even after getting an edit distance, do we still end up comparing the entire list?
No, I think as soon as we get 1, we return 2.
Yeah, but technically this exists in the list. Like it should have returned false, no?
Yeah. So can you repeat your example? You had one
So
string already.
the input, like let's populate the dictionary with HELL and
Okay.
HEEL, Helen Heel. Okay. Now I'm looking for HEEL.
Okay.
Okay, now we'll look for HEL. But in the map, my first string is going to be HELL, right? And I'm going to get an edit distance of 1. Right? So when we get an edit distance of 1, we assume that yes, this in the magic dictionary, this is a true case, right? We found the search. But if we continue with the list, we end up seeing that HEL actually exists in that dictionary. So it should have returned as false.
I think this should be fine, right? Because even if we have a HELL, but we have a one distance of HELL. So
Yeah.
is that not true? I think that should be true, right?
She's saying that
I
if the
think the
search
third
word is
condition is written explicitly, that return true if you can change exactly one character, otherwise false.
no.
Yeah.
Yeah.
So when we change exactly one character, we end up in another word in the dictionary, right?
We end up search there and return true, I guess.
Yeah, it should. That is what I think.
Yeah, but it doesn't match with the current word. No, that's a different word, right?
Yeah. So if you are searching for HEL, right? And so if we come through HELL, which is one distance apart, so it should be true, right? Because
yeah, that is true.
we are not looking for this one. Yeah.
Yeah, but the dictionary has this word, no?
No, it should be false, no. As in the example also, when the search word is hello, it returns false.
Very ambiguous case.
Okay,
Yeah,
actually, I
that
can
is
run the
because-
test case. Okay, let me run the test
Sorry,
case then.
if the search word is there in the map, then it should return false.
Yeah, but so in the map, like okay, like I think the approach is like, you know, we have a map with the count of the length of each word, and then a list of all the same length words, right?
Right.
So in that list, if HELL was the first word, followed by say BELL, then HEEL was there. Okay. So it exists in the map, but it comes very late. Like by then we would have already searched one word, is what I'm saying.
Yeah, right. I got you. So I think first thing we have to do is we have to check whether that word is there or not in our vector.
Yeah, directly that.
Yeah.
Okay.
I don't think that we should take this. I mean, HEL and HELL. I think if we search for HELL, it should pass because there is a word HEL using which we can get to HELL, right?
Yeah.
Yeah, actually, it passes in that. In the test case, if I use the same one, and if I search for HELL, then it says true.
So you input both in the dictionary, Santosh?
Yeah.
Oh, see, that's not right, no, technically though.
Why?
Yeah,
So that is what they say, right?
Why it's not right?
Because both the words exist in the dictionary.
It's not like that. Actually, if you have, if both of the words are there, that's fine. But whenever the word which you are searching, and when you try to find one distance apart for it, and if you find one distance apart, okay, whether your same word in the dictionary is there or not, that is not a problem. But only you should have one distance apart for that particular word. If you are able to find, then you can return true.
Okay. Okay.
As for the questions,
it's line of difference kind of.
Yeah, it's slightly tricky to understand, but if you actually, I tried the test case, therefore now I came to know.
Yeah,
So
but okay. In your input for the dictionary, which is the word you put first in the dictionary?
I think either of you put should not be a problem because I implemented the other way. I'm not implementing the way what you guys discussed.
No. So in your build dictionary, what's the order you've put?
Well, I said HELL, okay, and then HEELL.
Okay. And
then I searched for HEEL, sorry.
Yeah, but if your order would have been the other way, you would have gotten false, I think. Then.
No, because I'm not doing it that way. That is what I'm saying. I did it with the map way. I'm not actually looking for the order.
Yeah, why? I couldn't understand why the order would matter.
Should not matter.
Yeah, it won't matter, I think.
Okay.
That should not matter, right? You are a dictionary. You can have it other anyway.
Okay.
The order of actually inputting all the words in the magic dictionary, okay, whatever the order you insert, that is irrespective of your search.
Yeah, I agree. But then, like, just say, if it first encounters the word HEEL itself in the dictionary, right? So it's a direct search. So if you see in the examples that they've given, the moment they compared hello with hello, they returned false.
No, that is because you don't have the one distance for that.
Right. You should look at it that way. From that perspective, the reason you are quoting that hello returned false was that it has exact word. But I think we should look at it the other way, that it doesn't have any word which is one character distance apart from the hello word.
So if you had HELLO and HALLO, then things will change.
If we read this carefully, I mean, it makes sense what Ronnie is saying. We have to return true if we can change exactly one character in the word, irrespective of whether that string is there or not.
But actually, this problem was solved. Santosh, you stated, right? We will have a set of all the original strings, and even if you got a string with one distant difference, we'll check if that was already exist in that set. If not, then only we can return true.
Yeah, but that is true in that case, right? In this case.
Yeah.
Because in this case, if I do, I'm always having a count of 2, right? So in the first itself condition, I'm fine. Okay, so that is for the other one. If it's only a single word, okay, because the count will be only 1, right? Yeah, it's a bit not so easy to get this, but yeah, that is what it is. And also can we okay, can we actually show an implementation anyone has implemented? Want to just walk through it? Okay, I will just go through mine. Then can you unshare that? So, but I'm not implementing the way everyone was discussing. I just did it okay, this is the one, right? Okay, let me. Okay, so the way I did was using an unordered set to store all the magic words, and then an unordered map where I'm storing all the generic words with their counts. So this is the count map. And then here I come in this build dict, I go through each and every word, and then I insert that. Okay, this store insert is nothing but I'm inserting in the unordered set. And here actually I go and actually put each and every word and get all the generic words from that. So this magic words function gives me all the generic words. So where actually I replace each and every letter with a star. Okay, and then I just push that in my answer, which is a vector string, and then I return that in the magic words. So I'm just getting all the generic words with one distance, like putting star for each and every letter. And in this case, I come here back and again just dump that in the count, which is my unordered map, and just increment the count. So when I do a search, I do the same way again. I get the word from a search. Okay, and then I actually again convert that into those generic words. And then I try to find if it is present in my map. If it is present, then I go and look get its count. If the count is greater than 1, which is 2, I just return true. But if my count equals 1, okay, and it's not present in my set, okay, then only I return true. Okay.
So you're forming the regex for both of them, right? The strings in the map and also the search word.
Come again.
So the first thing you've done is like in your build dictionary function, you have obtained all the generic strings corresponding to one string, right?
Yeah.
And you repeat this for every string in that dictionary. Now you have exhaustive list. Now you are coming in this function search, where you are doing the same, right? For that search word also.
Right.
Because you're calling this function, right?
Yeah. So actually I just, that is what I'm saying. I'm using more space, but actually again converting all the search words into generic words, that is the magic words, and then try to find that if they are in the count. Count is an unordered map with a frequency count. And if my count is greater than 1, I say, okay, I have at least 2 words, that is fine. I can return true. But if it is only single word, then I try to find the search word, actually the original search word should not be in my set. If it is there, then actually I return false, or if it is not there, then my count is 1, then I return true. Because that generic word is formed by some other word, right? That is what it means.
Santosh, sorry, but if you are generating all generic possible strings matching that can be from the dictionary, how you are backtracking to find that if that string is in this map? Suppose same, you have BH okay, you have to find is BHEL has a matching on it. So BH star L will be there, and how you gonna match BHEL to BHL? How you finding that if it's available or not?
So come again, what you're saying? What the words you want?
So here there will be hello. Okay, so there will be one string H star double L O. Okay, so this string will be matched to our input H double L O. Okay, so that's why it returned true. Okay, है ना? Okay, so I'm asking how are you matching double H double L O to your parent string, to whatever is in your dictionary?
No, it won't be that way. I think it would be, both of them would be same, right? H star LLO and H star LLO.
Okay.
So
sorry.
Yeah.
What was the first word you said? HELL. Okay. And what is the second word you want to take?
Okay, so while putting this into the dictionary or the map, you are putting all possible strings of it, na?
Yeah.
Am I wrong?
Yeah.
So you are put H star double L O or HE star L O.
Okay, for this I will
just put
all
2-3 variations.
LLO.
Just put 2-3 variations.
Okay, this will be ELLO.
Just to make it clear.
Right, and then I put H star LLO. Okay, then HE star LO. Right, and then HEL star O.
Again,
HELL star. Okay, so this is what I'm going to put in my dictionary.
So now input is double H double L O. Okay, so how you wanna match if there is some like that?
And now you are searching for what you are saying?
Double H double L O.
Double H double L O.
Double L. Yeah.
Okay, so now what I do, this double HLO also I again convert into the same way. Okay, I say HLLO, right? Then H star LLO, right? HH star LO, and then HHL star O. Oh, sorry, O, and then HHLL star. Okay, so when I do this, okay, so I will find one map, right? H star LLO. This one will match. Okay, so when I say my count is 1 in this case, right? So count will be 1. So count will be 1, but if I look for this search word in my set, it is not there. because my store will only have HELLO, and therefore I will return true.
Okay.
Santosh, how are you handling HELL and HEEL in this?
Yeah, because it should have returned false then.
Sorry? No, he's searching for HHLO.
No. Can you make your test case in your build dictionary as HELL and HEEL?
HELL and
HEEL.
HE.
The count would not be that,
Okay, and what do you want to search?
HEEL.
Okay, other things are fine, right? Okay, so this is the first search. Actually, it should return true, correct?
Right.
What happened? Okay, yeah. So your HELL is coming true, right? This is your first one. What's the point?
But
then
then
count greater than 1, no?
Count is 1, I agree.
The count is 2
No. In this count is 2.
count is 2.
Count is 2 in this case. In your case, the count will be 2.
How?
It will be HE star L.
So because of HELL and HELL, you are going to form these two strings. HE star L will be twice. Okay, so if you break down HELL, okay, you will have star ELL, okay, and H star LL, right, and HE star L, right, and HEL star, okay. So now for the second one, if you see HEL, okay, this is the input which I'm giving in the dictionary, EL, right, and then you have H star EL, right, and HE
Got you.
star L, right? Yeah.
Sorry.
HEE star. Okay, so if you look at these two HELL, it is coming twice, right? So in my dictionary, it will always be 2. That count for this one will be true. And so when I'm searching for your HELL again over here, so this will be 2. And so this is greater than 1. And that is the condition which will actually make it true, return true, right?
One count would correspond to the distinct one and one for the same one.
One for the same.
Okay, got it.
Yeah, this is good.
Yeah, this is a very good test case, I would say. Yeah.
Yeah.
Okay.
This condition also.
Yeah, the condition is something very. It's not so straightforward.
Right.
Okay, so the other way to implement will be using a try. Right?
Yeah.
Okay. So try actually implementation will have more implementation, and considering 45 minutes, it will be too much, right? But I've seen people implementing try also.
So this would be, I think, for every string, you are obtaining that, like if we have a string of length L, you will have L configurations, right?
Yeah.
Right.
For all those L configurations, you are traversing your map.
Yeah.
So
it's a map, right? It's unordered map. So whenever you look into map, it's just O of 1. At least on a theoretical hypothesis, right? If the map grows, then it might be some more problem when it is rehashing and all that. It might take more time in some cases, but overall it should be O of 1.
Yeah.
Yeah, but it is too much of time complexity.
Space.
But still, yeah, space also.
I think the way Komal, I think, was explaining what that would have been the most efficient one.
Yeah, but actually in that case where all of the strings were about the same length, right? Almost the same length, and they were only 2 distance apart. Okay, then that will be a problem. Then that will be more of a time complexity, right?
L.
Yeah.
Yeah, that would be the worst case, but
yeah, but that will be a test case, right? And then it might
but
be a problem.
Yeah.
I implemented using that only.
Oh, you implemented which way?
The one we were discussing earlier, like using a single a map of like length and all the strings with that length.
Okay. Yeah, you can display here.
Yeah, we can go through that.
Sorry?
Can you share that?
Can you share? Yeah.
Yeah. Sure. So this is the approach. I have simply called a store. It's a vector of size 101 because we have like a maximum length will be 100.
Makes
So
sense. Yeah.
in this build dictionary, I'm just adding to my vector the string. So the index will be the size of the string, and I'm just pushing that string. And now in this search functionality, I'm just checking if the difference between the word, which is the input word, and the string, and any of the strings is, if it's 1, then return true, else I'll return false. And the def code is here. This is my def code. So just comparing if mismatch, if there is more than one mismatch, then I'll return directly. I don't need to go ahead, and otherwise I'll return mismatch. So here could be either 0 or 1. So if the value is 1, then I'll return true. Otherwise, I'll return false.
I think this is the exact one way they were discussing earlier, right?
Yeah.
Komal was discussing, yeah. Okay. So then, did you get it passed through everything or test cases?
I put it past, but the time was not so great. I think, yeah, but 52 minutes.
But this is a great time, I would say. I'm also almost getting the same time.
52, yeah, that's good.
Yeah.
So how is your comparison with others? I mean, what percent like?
Memory, I think memory would be a bit on the higher side, I think, for Santosh.
We can just resubmit. I'm not sure.
Well, if you look at in the MB, all these things you can store in an MB very easily. Yeah.
Some error, I think.
Actually, I was created a different class because I was trying for the try solution as well. So that is why.
Okay. So Ronnie, one thing, can you go to the difference part where you're calculating the difference?
Sure. Yeah.
So what is like this first line auto def equals to square brackets? How do you?
So it's just like it's just a lambda function I've created because it will stay inside. The scope for this function is inside only the search functionality. So I just created a lambda function, and we just call this lambda function. So auto is like the return type. Def is the name of the lambda function. This is like the scope operator. So let's say I had an unordered map here. Another map, I don't know, let's say int a, and I wanted to access that map inside from this lambda function, and I would need to just pass this function, access this by reference. So this is for that. And now this is your normal input argument, and this is the function definition.
Yeah. Okay. So currently you have this as empty, right? So you're not using any parameters.
Right. Any parameters inside above that function, right?
Got it. In the function you have defined that lambda function.
Right. Exactly. I don't know. Maybe we here.
But I think this is a very good implementation.
So it's 17%. It's not that great, look.
Yeah, but it's a nice. It was 17. Okay. Yeah, but it's good. Earlier it was,
it's much better. Yeah, this is good. So the way she was discussing actually is a efficient way of doing it, right? That concludes. Now he has a working version also.
Yeah.
Yep.
I was thinking regarding the try approach because I thought that maybe using try we could actually do better, but like the code-wise try would have been like pretty big as compared to these.
Yeah. Try actually is a huge implementation. But yeah, it can be done. It's not it's not very difficult also. Yeah.
So where are you initializing this RHS?
Where? Line number 18?
In the search function. Yeah, I can't see your line. It's the font.
So Yeah, this is my line 18.
Yeah.
You're on this line,
Where
right?
I'm initializing this RHS.
This is like argument, right? So this is like argument to my function. So consider this def. So I will just rewrite this line. So it's like int def this. So this line is same as this line.
Okay, so what is this RHS basically? It's the search string.
It's a parameter for that diff.
It's the parameter, right? So here on line number 31, here I'm passing these two strings, right? Word and str. So these are just two strings here. This LHS is the word and RHS is the str.
Okay. Okay.
And this comes more handy if you're
Is
using
argument.
priority queue or maybe a comparator or an operator,
Right,
for sorting and all
right.
that. Yeah. So it's very good.
Okay. Okay. Yeah, I got it.
Yeah, good. Yeah, thanks, Rani. Thanks for sharing this. This is the way actually we can conclude that what she was saying was the right way to do, because it's more time efficient.
Yeah, please share this code, Ronnie.